Okay, so the first set of videos that I'm making myself are for the second module, the module called Transformations. And this is not transformations of functions like you may have seen in the past, it's just objects. So this is the first video. This is about reflections. So when you think about a reflection, sorry this one looks like a mess, but think about the line as like a mirror. So you're trying to figure out what it would look like on the opposite side of that mirror. So every step you take toward the mirror, so does your reflection. And when you step back, it steps back. So the point is that whatever we did on one side, we want to do the opposite thing on the other side of the line, which may sound crazy right now, but hopefully you'll see in a minute what I'm talking about. So the first thing that we want to do on number 1 is to reflect the figure across the x-axis. The nice thing about reflecting across an axis is that to get to the line, you only either have to go up or down, or left or right, not both. So this is our line of reflection. So the question is, to get from R to this point, what do we have to do? We have to go from R up 3. So we now go away from R3 and plot that point, and that's the new point that R has created. On A, we need to go up 2 to get to the axis, so we go 2 more and plot that point. And for C, we have to go up 6 from C, so we go up 6 more from there. And I will attempt to draw a triangle. The rest of the points are just the segments between those vertices, so those are the only ones we really have to map. Now, on part 2, we're doing something slightly different, but not horribly different. So, the line x equals 1, it's not an axis, of course, but it is parallel to the y-axis. So it's still vertical. So we're going to this line here. So I just have to go from this point A, I have to go 3 to get to that blue line. So I go 3 more and put a point. From R here, I have to go 1, 2, 3, 4, 5, 6 to get to the line. So I go 6 more and plot the point. And from T, I also have to go 6 because see, those are on a vertical line together. So I still just go 6 more. And there's my new triangle. So in transformations, we have the image and we have the pre-image. And really most things in math are defined in ways that make sense with the words. Both of these are images, of course. They're both images of a triangle. But the word pre indicates before. So the pre-image is always going to be the one that came first. In this case, it's the black triangles. So triangle CAR is the triangle we started with. And the way we note the new, I see I've skipped 3. 3 just asked us to label the points on the graph. So the way we do it is by adding a little prime, which is, if you're writing it by hand, it's an apostrophe, but it's just straight. But if you're using a computer to type it, then you have to use apostrophe. So the point that I got by mapping R over is called R prime. The point I got by mapping A over is A prime. The one I got by mapping C over, C prime. Okay, so this point came from A prime, this one came from R, and this one came from T. So that little apostrophe just means that it's the image and not the pre-image. So again, triangle CAR was the pre-image because it came first. And now there's 3, which we've already done. 5, we talk about the notation, but it's called a mapping. So I took triangle CAR and I mapped it to triangle C prime, A prime, R prime. Mapping really, functions are mappings, but it's a mapping if you go from one point to a defined other point like we did just now. So the way we notate the mapping is with an arrow. and the arrow means goes to, basically. So we started out with C, and C went to C prime. C was -5, -6. C prime is -5, +6. A was -4, -2. And if you're doing these in order, you just reviewed plotting points as well. A prime is -4, +2. R was 0, -3. R prime is 0, +3. Okay. Another thing about reflections and a couple of other of the transformations we're going to talk about, but in particular right now isometries. Again, if we look at the word, if I were to use an isometry, so a reflection, remember, is acting like a function. It's a thing we're doing to it. If what I'm doing to it is an isometry, then it means the objects are isometric. Iso, which you've dealt with in chemistry and physics, means equal, and metric means measure. So an isometry is a map where the sizes are all the same. So the distance between all the points is the same. You haven't punched a hole in it, you haven't stretched it, you haven't skewed it. It's the exact same object, and if it was a piece of paper, you just picked it up and flipped it around and maybe flipped it over. So that's what an isometry is. It is a mapping that preserves distance, that preserves measure. So now we want to graph the line y equals x and then reflect across that. This, of course, is not parallel to either axis. So this is like this line. Well, that's far enough. Okay. So because this time it's not just going up and down, with the slope of this being 1, what I need is a perpendicular situation. So I actually need kind of a slope of -1. So to get, here's G. One way to get to the line from G is to go up 1. So if I go up 1, I can instead go left 1 and map that there. I could also consider that I'm going left and go up instead. A, let's just look at one way to get to that line, is to go up 3. So I would go left 3. Label these G prime, A prime. Another way is I could go up 1 and to the left 2. And so what I would do to reflect that is the 2 I went left, I'd go up, and the 1 I went up, I'd go left, and I'd still end up in the same place. From Y, I can get to the line by going 1, 2, 3, 4, 5 over. So I can go from that point 1, 2, 3, 4, 5 up. At this point, you could probably go ahead and sketch the other point because this is clearly a rectangle, but from R, I could get to the line, say, by going 1, 2, 3, 4, 5, 6, 7 up. So I go 1, 2, 3, 4, 5, 6, 7 to the left. It doesn't matter what path you take to the line, it just matters that we're perpendicular. So perpendicular to that line needs a slope of -1. So the up and over needs to be the opposite. Then I can sketch this in. And I should have put y prime, r prime. And then over here we have the line y equals -x. Having issues today. -x. Bear with me while I have pens go crazy. -x. So there's my line of reflection. So from A, I go 1, 2, 3, 4, 5 up, so I go 1, 2, 3, 4, 5 over. And this has a slope of -1, so that's why we need the reflections to be kind of a slope of 1. So that's A prime. M goes 1, 2, 3, 4, 5, 6, 7, 8, 9 up. 1, 2, 3, 4, 5, 6. Oops, lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9. M prime. Y goes 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's Y prime. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. R prime. Okay, so there's the reflection across that line. This one we are going the opposite direction. So we've been given a reflection, and the question is, what is the line over which it reflected? So on this one, you can see that it's been reflected vertically because it looks like somebody picked this one up and just flipped it over that way. So it should be a horizontal line. If it's been vertically flipped, that's a horizontal line. So we just need to figure out what. But we know for however many times we went up, we kept going that much farther whenever we mapped over a horizontal line. So this goes 1, 2, 3, 4, 5, 6 total between these 2 points. So that means that half of the way of 6 got him to the line. So this is here, so that there's a distance of 3 there and there. This one there's a distance of 6, distance of 6. So it's reflect over this line. Any horizontal line is going to be y equals some number because it has 0 slope because it's horizontal. And in this case, that number is 1. So y equals 1. On this one, it looks like it's something that had like a negative x type slope because we just saw one like that. So this is one of those things where from this point to this point, it's got to be in between this way. Okay, so we can look and see that there's basically 2 little diagonal blocks between. So we can assume it goes through here. That's the point between those two. The point between these two, we've got 1, 2, 3, 4, 5, 6 total little diagonals, so 3 of them. So we can sketch the line this way. We also could have decided to go, let me switch colors here for this. We could have decided to take this line here, the one that goes horizontal, because remember that we would have gone to the right or up to hit the line and then gone either down or to the left to meet it. So we could say I went right from here and down from there and they intersected there. And maybe from here I went up and that same point over here, then I would have gone left and it would have intersected right there. And then you've got 2 points, which is enough to make a line. So this line of reflection is just y equals -x. It has 0 y-intercept and it's rise over run, so -1 over +1. So y equals -x. On this one, we want to show the mapping for each coordinate point. So the first one we want to reflect across the y-axis, and this number 9, it's a little bit interesting because it's going to intersect itself. So it's on the y-axis, which means, it covers it, which means there's going to be some on kind of top of each other. So we're going across this one. But because it's still just a vertical line, we still just have to look at, I go left and then I keep going left, or I go right and I keep going right. So from R, well, I guess we'll do B first since this is listed BAR. B is -3, -6. Now when I flip over the y-axis, you may have sorted out by now, it's just going to change the sign of my x value and my y value will stay the same. So you might already know this is going to be 3, -6. But if not, let's look from B. 1, 2, 3 to get to the line, 1, 2, 3 more to get to the image. That's 3, -6. A is -2, -2. So if it's just going to change the x value, then it'll be 2, -2. But if you want to just kind of reflect it, go right 2 to get to the line, so write 2 more, and there's A prime. R is +2, -3. So when I change the sign of that x value, it becomes -2, -3. Or I go left 2, so I keep going left 2. Okay, and then number 10, we want the line x plus 2. So that has a y-intercept of 2. Rise over run is 1. So here's the line. It has a slope of 1. So if I go to the right to get to it, I go down to go ahead and get that image point. So M starts out -5, +4, and then it goes 1, 2, 3, 4, 5, 6, 7, and down 1, 2, 3, 4, 5, 6, 7. So there's M prime, which is 2, -3. A, I would go 1, 2, 3 to hit the line, so 1, 2, 3 down. A prime. So A's -2, 3. And A prime is 1, 0. And T, I can go down to hit the line, 1, 2, 3, 4. So to the right, 1, 2, 3, 4. T prime. T was -5, 1. And T prime is -1, -3. Okay. So for 11, we want to reflect across y equals -3. Y equals -3 is a horizontal line. Oops. Let me get back there. It's a horizontal line, so those we kind of like the best. -3. But you may not like it best when it runs through your triangle. But it's still fine. A goes down 1 to get to the line, so down 1 more. T goes up 1, 2, 3 to get to the line, so go 3 more. R is on the line, so it stays put. So there's the reflection. And then over here, we've got y plus x equals 1 is the line we want. So that's y equals -x plus 1 if you prefer the slope-intercept form. we can say in this form, this is standard form of a line, so we could say if y is 0, then x is 1, so 1, 0. And if x is 0, y is 1, so 0, 1. Those are 2 points. You can really plug in any x you want and solve for the y, or vice versa. Okay, so t, I can go down 3 and hit the line, so then I would go left 3. P, I could go down 1, 2, 3, 4, 5, 6. So over 1, 2, 3, 4, 5, 6. A, I can go down 1, 2, 3, 4, 5, 6, 7, 8. I hope I didn't miscount. 1, 2, 3, 4, 5, 6, 7, 8. And so that last one was A prime. This one was T prime, P prime. So hopefully you get the idea and you have some way that makes sense to you to do this if the counting method doesn't work for you. And I will be back with you on the next kind of transformation, but that'll probably be Thursday. Okay.